Hello, my name is Neil. Welcome to this MECABRICKS video demonstrating the new animation nodes feature. I've only been using MECABRICKS for a couple of months, and I've only been using the animation nodes feature for a couple of hours. At the moment, my understanding of it is very basic, but given that there's no tutorials or documentation available at the moment, I thought it would be worthwhile just showing you the basics. I have a video for how to do rotation of a single brick or a collection of bricks, and this video is to show you how to do some basic vector animation or movement of a brick, and then maybe at the end I'll combine moving and rotating. So as with the previous video, what we need to do is go into the animation nodes section, which is this icon up here, which is off by default. This gives you the node tree view. This is where you're going to write your code, your functions, to determine the movement of the objects. So what we're going to do is do something very simple. Just take a single brick, move it over there, and the object here is just to move it in a straight line like that over a couple of seconds. Okay, so in the node tree view we've got number of frames and frames per second. So say we wanted this to last for 4 seconds for argument's sake. So 4 seconds at 24 frames per second, not 24 times 4, 96 frames in total. Okay, so 96 frames, that gives us effectively our length. So this brick will move from here to here in 96 frames. So as with the previous video, first thing to do is to get a value that you can use to trigger the movement. So in nodes here, animation, use frame. And what this does is it holds the value of the current frame. And pressing this button will obviously sequentially increase the frames from 1 to 96 and then back again. Okay, so within nodes, let's have a viewer. Put this up here, connect the two together, and that just shows you the value, the current value of frame. So as I move, that value increases. Okay, so the next step is to actually deal with the movement. So all we're going to do is basically increase the value of the vector, the x vector. So what I need for that is a number math node. What we will do is we will feed in the value of the frame, and we'll have a constant value here, 1. So then if we create another view node, I recommend using these view nodes as you build, especially when you're not very experienced like me. And as you play it, you can see the value increasing. Now you could have taken the value straight from the frame, but you can use this value to control the speed. I'm not quite sure whether we'll need it yet, but we'll leave it for now. Then we need the convert node. So vector combine. There we go. So what we're going to do is going to feed that value from the mathematical add the x-axis, and then we need to apply it to the object using a object transform output. Okay, so we've got that value going into x-axis, so we're going to use location this time. So this one's location, this one's rotation, so location. Then put that value into location and play, and nothing happens. Why? Because we haven't picked the object. So you select that picker, click on your object. Okay, there you go. So say you wanted, you can see at the moment the frame count and the value being fed into the transform object is the same. But what you can do is you can add different values. So if I change this to 2, for example, that effectively does, it speeds it up. Added 2 to it. Now, if you want a more dramatic increase, if you did multiply, then what you can do is, so if you multiply by 1, it just remains the same. If you multiply by 2, then the distance doubles. You can see that if you look at the two views, 95 frame is 195 in the viewer. Okay. For now, just put that back to 1. You could, in fact, if you wanted to, if that was the desired effect, you can take out this maths node, just put the frame straight into X. Don't need that, and it'll have the same effect. What you're basically saying is that for every frame, move the value of 1. So if we get the viewer node, look at the value coming out. Basically, what you can see is that the vector value for the x-axis is just increasing the frame. If you wanted it to come at a diagonal, for example, or you wanted it to move across 2 axes, then what you can do is you can link it into Y as well, and over here place Y, and now it's shooting off at an angle as well. If you wanted Z, do it to Z instead. You've got to make sure that whatever you connect your input to is what matches over here. And shooting off at a diagonal now. Okay, and where this gets quite complicated quite quickly is that you can transform any of the values coming in. So say you were quite happy, get rid of that, quite happy saying, right, the x-axis is just 1, back around the other way, x-axis is just 1. Say you wanted one of the other axes to be a greater number, then what you can do is just transform it before you feed it in to the combine vector. So if you take a math node and do multiply, and say my first input is my frame number. Always have trouble connecting these noodles. I think it's because I do it the wrong way around. And then if I put 1.5 and then just connect a viewer to that, what you can see is in frame 1, the value going directly into the x vector is 1. I'm not doing anything with it. But the value of this very complicated math sum is 1.5. So similarly at frame 2, you've got 2 here and 3 here. So they're actually now operating at different rates. So what you can do is, if I take that value coming out of the mathematical formula and put it into y, and then turn on y for the location, basically what that means is that's the x value and that's the y value. Which will obviously determine, in this case, the degree of the angle. So if I change this to 3, so now it's 3 times, you can see that that's sharper angle. Okay, now it changes. And the possibilities for movement are endless, I'm sure. But yeah. Okay, so that's the end of the demonstration for basic movement. And what I'm going to do now, just to round things off, is just try and show you how to do a move and rotate at the same time. Okay, basically combines the first part of this video with the rotate. If you haven't looked at the rotate video, I suggest you do. Okay, so what we're going to do is, as we move it, we want to rotate, try and rotate this brick across that line of movement for 360 degrees. I'm going to make my life a bit easier and change the frame count to 180, which basically will mean that it'll take 180 frames. Just need to zoom out a little bit. 180 frames for it to move across its position, and that makes it easy because that means that for every 1 step forward, it has to rotate by 2 degrees to get to the end point. I managed to get my view up here. Wrong button. Okay, so let's put a rotation on that. So our input is going to be the frame. We are going to convert that frame number degree to radian. So frame number comes in. No, that's not right. So we want 2 degrees as radians. We put a viewer on that. That's our constant value, which is 0.03491. And then what we're going to do is we're going to take the frame rate number math, and we're going to multiply our constant number and our frame together. Make this viewer. As you can see, play the radians going up 2 degrees per frame. So on frame 180, it should be equal to a whole circle, 6.28. That's right. So then what we're going to do is going to feed that value into a combined vector. Combine. The x-axis. Feed that into rotation with x-axis selected. Y there, because we've got no Y value for location. So I think that's it. Except I picked the wrong axis. Not very good with my axes. So just move that to Y. Change the rotation to Y. Right? Yeah, that's right. So as you can see, what we've got going on there is the movement and the rotation at the same time. Not sure if I need both of these combined vectors. Just get rid of this one. See if I can feed this one into Y, that one into there. Yeah, so I didn't need both combined vectors because that's what this node does, I think, is it combines the information from multiple inputs into a single output. So you can see what's happening there is X is going in and is being fed X to location. Y is going in and is being fed Y to rotation, which is what gives you the two at the same time. Okay, and there's a couple of other things that I've learnt which might be worth showing just at this moment, which are on the animation nodes. So we've got delay, which allows you basically to place a delay of an event. So I think what we can do with that is if I take that off and put this value into here and this value into here and then delay it in some way, what that does is it controls when the rotation starts. If you, for example, you're doing a single node tree for a very complex animation, you've got multiple steps, what you can do is you can delay the second step while the first step completes. Get rid of that. And then the other one is repeat. So you've got loop and ping pong here. So in terms of the movement, so if I take this frame value and place it into time, then place the timeout into X. So that's now a loop for 10. That's basically doing is every 10 frames, it's just resetting on a loop. So it's limiting the movement basically. If I wanted that to run for half, I could change it to 90, and then it would loop at 90. As soon as it gets to 90, you see it kick back, start again. And the other one, which is quite nice in here, is ping pong. Basically, we'll bounce it backwards and forwards. Yeah, that being quite nice if you've got an animation for a bucket or something that you want to show opening and closing. You can ping pong it backwards and forwards. Just notice that I don't have my rotation on because I've lost it. Put that back into Y. But you notice there that my ping pong is only applicable to my movement. It's not applicable to the rotation because I haven't told it to be applicable to the rotation. So if we just get another animation repeat, pop that there, put that into time. To Y. Put that into ping pong. Should see as well. Okay, I'm beyond my learning, beyond my level of understanding, so forget that. Okay, so I hope you found that video useful. We've all got to start somewhere, including me. Next step for me is to try and learn what some of the other animation nodes do. And when I've worked that out, I'll probably do more videos. Okay, thanks, bye.